channel. So today we'll be solving divisible and non-divisible sums difference. So we're given n and m. So num1 will be the sum of all integers in the range 1 to n inclusive. They are not divisible by m. And then we get num2 is the one that are divisible by m. And then we want to return the integer num1 and num2. Num1 minus num2. So an easy solution. So this is just we go through iteration. So we define num1 equals to 0 and num2 to be 0. So we go through in the range inclusive from 1 to n. And then if I is not divisible by m, then we can add that to num1. Otherwise, we set this is equals to num2. At the end, we just return num1 minus num2. So this is one way of doing it. So we go up to n. Sorry. We go up to n. So the runtime will be of n, and then we don't define any new thing. So this space complexity will be of 1. Right. So there is actually another way of doing this, and let's look at it. So another way of doing this is just use a math, right? So this will bring down the time complexity to be of 1. And yeah, I can show you how to do this. So first we can notice like the pattern of this, right? So if let's say this is n equals to 10 and m is 3. So if we think about this from 1 to 10, so not divisible by 3 will be 1, 2. Divisible by 3 will be 3, 4, 5. This is 6, and then 7, 8, and then 9 and 10, right? So one way of thinking about this is notice what does this represent? This represent m, right? For the first one will be m. And the second time we encounter this will be 2 times m, which is 2 times 3. And this will be 3m, and then go up. So one way of thinking about this is that we can use geometric series to think about how many times we can do this. So first, if we just try to do this, this will be m plus 2m plus 3m, blah, 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 right? But so far, I only have 1m, 2m, and 3m. So if I factor out m, I can see this is 1 plus 2 plus 3 all the way up. So now we know, because we can just look at it, we know there are 3 times for this. But how are we getting like how many times we can do this? We can define a variable k, and then it will be n divided by m, and then we take the flow of it. So this is saying that we can have this k to see how many times we will have this divisible part. So let's say in this case 10 divided by 3 will be 3 point something. We take the flow. We know that the numbers that divisible by 3 or divisible by m will be at most k time. So in another way, we can also say this to be m times 1 plus 2 plus something all the way up to k. And then by geometric series, we know that this is a increasing series by plus 1. So if we want to calculate the sum of this, we can just take k. So the thing is, like, you can do k times k plus 1 divided by 2. Right? So this is what this bring up to, and then we have a m at the front. So in case no one knows this before, so this is a classic questions of geometric series and how Gaussian find this. Correct me if I'm wrong. I think it's Gaussian. So it was given a task that where you want to sum up from 1 to 100. 1 plus 2 plus 3 plus 4 all the way up to 100. And then the clever way he found is that if you add 1 and 100, it will be 101. If you add 99 and 2 together, it will be 101. And then 98 plus 3 will be 101. And then there will be 50 of them. So the way of doing it is using 100, which is the n, times n plus 1, which is 101, and then times how many number of series it has, 100, divided by 2, because it's from 50 of them. So this is what give you the k times k plus 1 divided by 2. So this will tell you what num2 is. which is this term. Now we'll tell you the sum of the num2. But now we want to see what is the sum of num1, right? So we go to other place. There's an easier way of doing it as well. So since we know that the formula of this k times k plus 1 divided by 2 in geometry series, we can also see this as we want to do 1 plus 2 plus whatever up to n. Right? So in this case, you can also set the total sum will be 1 plus 2 plus all the way up to n. And in Python, for sure, you can go like for I in range 1 to n plus 1, and then do like the sum plus equals to I. But you can also do the math, which give you all of one runtime, which is the same, right? N plus 1 will give you the n plus 1 thing that you want, and then you want to multiply by n divided by 2. So this will give you the total. But how do we find num1? Since we know num2 already, so we can say num1 is equals to total minus num2. This will give you num1. And because our idea here is just find num1 minus num2. So if you switch around, you can also find that total is equals to num1 plus num2. So I think so far this is okay. But in other way, I think I don't have to show you this one. So our goal is to find num1 minus num2, right? So if we ignore this step, so if we want to do num1 minus num2, and we know that num1 is equals to total minus num2, so we can substitute this for this. So in this case, we can say if we want to minus num2 on the left side, we can also do another minus num2 on the right side. So since we know that the total here is n plus 1 times n divided by 2, and then we want to minus 2 times of num2, right? So we can say we minus 2 times num2. So what is num2? Num2 is this, right? Including the m. So nums2 will be m times k plus 1 divided by 2. And then we can cancel out this 2, and then we get our final math equation will be this, right? And whatever this is, and then minus m times k plus 1, because the 2 get cancelled. So yeah, let's try to just code it out. So as we said, we want to find the floor of n divided by m, and then we just want to return n times n plus 1 divided by 2, and then minus k times k plus 1, and then times m. If we run this and we submit this, then this will be all of one runtime, which you only need to do the math. For space complexity, also all of one, because we're not storing any extra data structure. All right, thanks for watching. See you in the next video.